Hello, in this video I'm going to explain another hardware interfacing program, that is 8051C program, to generate sine and square waveforms using a DAC interface. So for this, the theory part I can say is, so DAC stands for digital to analog converter. It's a device widely used to convert digital pulses into analog signal. Okay, there are two methods to convert digital to analog widely used, that is a binary weighted and R2 to R ladder type. So we are using DAC 0808, which uses R2 to R type. I can see the some theory part. Okay, so the IC we are using is MC1408, which is nothing but DAC 0808, which is a digital to analog converter, which uses R2 to R ladder type conversion. So here, okay, the actually 8 inputs, digital inputs we are giving, and you're going to expect 2 power n analog levels. That is, to if n we are giving 8 inputs, to this DAC is actually having 256 discrete voltage levels. Okay, so if I give digital input as 0000001, it will give some output voltage according to the formula that is called as resolution. If the number of bits are more, then you'll get millivolts, microvolts, analog voltage is also you're going to possible. So if you want to have good precision, then the number of bits input bits should be more. Okay, compared to 4-bit DAC and 8-bit DAC, 8-bit is better. And compared to 8-bit, 16-bit is better, like that. Okay, so in the 8 we have 256 discrete voltage levels, and step size is, if I give LSB is equal to 1, okay, then how much analog voltage you are getting, that is actually called as step size. So if I increase 111 analog digital input, so the waveform will increases like staircase. Okay, so it will reach maximum when all the digital inputs are 111. So you're going to get the maximum output value. So in this chip, digital inputs are converted into current. Okay, digital inputs we are giving in zeros and one logical binary inputs. So the IC will give the output in output current. I out is given by I reference into D7 is MSB, D7 by 2 plus D6 by 4, D5 by 8, D4 by 16 plus D3 by 32 plus D2 by 64 plus D1 by 128 plus D0 by 256, where D0 is LSB, D7 is MSB, and I reference is the input current. Okay, must be provided into pin number 14. Generally 2 milliamps is used as I reference. Okay, I'll show the diagram also how to connect. Okay, after that I'll show the interfacing diagram also you need to write. So this is about DAC IC. So IDC DAC 080 is a digital to analog converter used to convert the digital input to analog signal output 8-bit. So application DACs include music players, TVs, mobiles, etc. Then pin details of DAC 0808. So pin number 1 no connection, 2 is ground. Analog inputs, okay, digital inputs are given from the pin number 5, 6, 7, 8, then 9, 10, 11, 12 up to here. So this is D0, LSB, D0, D1, D2, D3, D4, D5, D6, D7 is MSB. So these are the digital inputs you have to give, and you're going to get the output here, I out. Okay, pin number 4 is the output. So and we have to give reference voltage. The reference current is given to pin number 14. V reference minus, and VCC is pin number 13. So these are the digital inputs you can see here. A1, A2 is nothing but digital inputs. And the connections. This diagram you need to write in a record. So this is 8051 microcontroller. Port 0 is used and we are sending digital input to the DAC. So port 0 should be configured as output. By default, all the ports are 0. So it acts as output only. If you want to configure as input, you have to give it as 1. So it is output only. So port 0.0 to port 0.7, 8 bits are connected to the D0 to D7 pin. That is pin number here. Diagram is there now. This is A1 to A8 now. This 5, 6, 7, 8, 9, 10, 11, 12. These pins we need to give this D0 to D7. D0 is LSB, D7 is MSB. Reference voltage is this. It is connected through 5K resistor. VCC is 5 volts. Okay. This is I out. This is I out connected to the op amp. Okay. So here it converts current into output voltage. Okay. This op amp converts current into voltage. So you're going to get analog voltage. If I give all the digital inputs as 0, you're going to get 0 volts. If I give all the digital outputs as 1, you're going to get up to 10 volts. So this you can change by changing the reference voltage also. You can have 0 to 5 volts also, anything. So for this diagram, 0 to 10 volts, and this you need to connect to some CROs. So this is analog. Now I'll explain. This is a assembly language program to generate a square wave. How to generate square wave, I will show you. Okay, first I'm sending digital inputs as 0, 0. Okay, and you have to send it to port 0 or port 1, any which port it is connected, we have to send it to that. After that, you have to call delay. So this value will be there, and you're going to get analog output as 0, 0. This much delay, it will stay there only. After that, port 0 is sent with maximum value. All the digital inputs as 1, 1, 1, 1. So you're sending FF. For that, according to that formula, it is going to get some digital analog output, because it converts digital to analog. If all the digital inputs are 0, analog output is 0. If all the digital inputs are 1, 1, 1, it will give maximum output of 10 volts. Okay, FF is digital inputs, analog output will be 10 volts. Again, after some delay, again give digital inputs as 0, 0, call delay. Again, give digital inputs as FF, call delay. So this is a delay program. Okay, it is a 8-bit mono or not with FF, DJ in Z R naught. So until R naught becomes 0, every time it will decrement R naught. So it will stay there only. Delay program is not going to do anything. It will just introduce delay. Okay. So you have to maintain 0, 0 for some delay. Again FF some delay. So this will give you square wave. So now I will show the C program, how to write, how to generate. First program I will explain the syllabus. Okay, first I'll explain square wave. After that, I'll explain how to generate uh, a sine wave. So I'll stop the previous program, remove this. You have to stop debug, stop the program, stop debug. Then only you can delete the program. It will be there in your folder. Whenever you want, you can add it. Right click, add new item to the source group. Select C file and type square sqr.c. Okay. So I already have. So I will add square dot. I'm using add existing, but you need to add new item. Select C file. I'm existing already. I already typed program square wave. Double click on it and it will open. So this is C program. Okay, include register 51.header file, void delay, open bracket, close bracket, int I. Yeah, int one more for I is equal to I less than 922. I means int means it is 16-bit. You can give maximum of FFFF, that is 65,000, 64,000 something, 65,530 for some values there, no? If you convert FFFF to decimal, you will get that much value you can give here. So for I is equal to 0, I less than 922, I plus plus. You can give any value to that value. Okay. But if you declare char, char, maximum you can give is 255. Okay, 254 you can give. So since it is int, you can give maximum 0xFFFF. Correspondingly, decimal value you have to give here. So any value you can give here. Then void main while one for continuous run. So port 0 is sent with maximum all the digital inputs as digital input is all are 1111. All the digital inputs as 1111. FF means 111. You have to call delay. After some delay, you have to give digital inputs as one more digital input, that is 00. We are giving extreme. All the digital input 0, all the digital inputs as 1. If you want to decrease the amplitude, you can give A or 9999. Any value you can give 99 also. Sorry, FF, any value. Maximum is FF. This. So call delay. Now compile this program. Okay. We are getting 0 errors and 0 warnings. So we have to select in the options. Go to output tab, select create X file. This option should be checked in. Okay. Then only you can get this message down. You are getting this message creating X file. So where you created, I created a folder in 2023 E1 8051. There X file will be generated that you have to browse. Okay. That X file you have to browse, and you have to convert this X file into bin file. Then using ISP program, you have to browse that bin file and program it. Once the program is showing successfully programmed, you need to connect DAC it to the CRO, cathode ray oscilloscope. You can observe square waveform. Okay. Here actually I have recorded video previously recorded. So where you can see only you can observe this output. This is for increasing. See, this is assembly program to generate triangular wave. So for this, we are sending digital inputs as 00. Send it to port 0. After that, increment A. So if I increment A will be incremented by 1. So now we are sending digital inputs as 0000001. Okay, it will give the analog input next level. Again, we have to compare whether accumulator has reached maximum or not. Compare C means compare accumulator with maximum FF. If not equal, jump back to up. So every time it will increment and send. So corresponding digital is converted into analog and it will reach maximum of 10 volts. Once it reaches FF, once it reaches FF, okay, you have to go down. So you have to start decrement here. So you have to decrement each time and you have to compare with 00, whether it is reached or not. If it is not, jump to the label down. Down is here. So every time you have to decrement by 1 and send it to port 0. So you can get like this. This is analog triangular type of waveform. Similarly, for this RAM type, there is no need to decrement. Okay, no need to decrement. Move A with 00, send it to port 0, increment only, no decrement. So compare with FF. Until it reaches FF, every time we have to send that accumulator value to P naught. Once it reaches FF, once again after FF, if we increment, after FF, it becomes 0 only. So once again, we have to send more peanut short jump to back. So it will reach FF. Once again, if you do increment, FF becomes 00. So increase FF 00, increase FF. So you're going to get this output. Okay. Now, how to program? I will show. This is the program for ramp. Okay. So you think that you are doing a square wave, you should get square wave. So I will explaining how to program. Okay. So you have to open ISP program. This will run only in Windows XP. It will not support ISP program, not supported in Windows 10 or Windows 11. So you have to use while booting, you have to select Windows XP, and we're using Keel 3 software. So you have to use ISP program. So once you click on ISP program, so in the target for option we selected create X file, so that you have to browse. Okay, You have to browse the text file and you have to convert the text file to bin file. So this is the X file generated. Next, you have to type bin file. You can write in the bin file. Okay, first you have to browse the text file. For example, if I created a project X square or any project name, the same project name dot X file will be there. Next bin file also you can give the any label. You can give square dot bin. Okay, instead of ssr dot bin, you can give square dot bin and convert to x to bin. Then it will generate whatever name you are given. That bin file will be there. You have to load that bin file. You can load that ss dot bin or square dot bin, and you have to click on program. So it will show the message. Okay, it will see chip successfully programmed. Chip successfully programmed. Once it is successfully programmed, now I'll show the kit how to connect. So this is the kit 8051 kit. This is adapt through adapter. This is adapter. You have to give the power supply. This is connected to the 230 volts, and this is DAC kit. So the here we have DAC 0808. This is DAC 0808. Okay, this is, and here two pins are there. This brown color is positive, black color is negative. So negative should be connected to the ground. This is a CRO, cathode ray oscilloscope. This is a CRT screen. It has two channel, channel A and channel B. You can, it is connected to channel B, or you can connect to channel A also. And ground should be released. You press ground and adjust this. Turning this knob, you adjust this one to horizontal level. Click on this button. Ground you have to release. After that, here if you are connected to this, through this you can adjust this level. Okay, and this you can adjust to 2, this mark, this knob. Okay, vertical scale you can adjust to 2 or 5. Okay, then you release the ground button. Connect red, this has positive and negative. Red color you connected to the brown color of this DAC. Black you connected to the negative of this. Okay, please check whether this IC is there or not. Sometimes if this IC is not working, you will not get the output. And this DAC should be connected to this pin. Okay, which port you connected now, that you have to use. You have to see the port number. This kit is connected with this, so you have to use that one only. 8 pins. Digital input we are sending to this. So you have to connect this pin to this. They had mentioned here. Okay, you have to use that one only. So after that, once you program, you can check the output now. I'll show the output. See here, brown is connected to the red, black is connected to the this. So this program, and in the CRO you can see this program is demo for ramp type, but you can expect square wave. Instead of this, you're going to get square wave. Okay, you're going to get square wave. For sinusoidal also you're going to get. So this is how to see the output in it. Now I will explain how to do it in simulation. In the simulation, you have to click start debug. Again, go to you have to delete. You have to open this logic analyzer. Go to setup. Then delete previous one. Okay, which port you are using? Port 0. So you have to add port 0. Okay, port 0. So here uh, is a DAC. Okay, all digital inputs are converted into analog output. So in the port 0 we are sending analog output, so let it be analog only. You can change the color of this, either green color or red color, whatever you want. So close it. Next click on run now. So you'll get like this. So you click zoom in. So this is zoom in. Stop here. You can find the frequency of this. Click here. Okay, then click on the cursor. So if you go here, you can stop here, one full cycle, on time, off time. So on time, off time, you see the difference here. Difference is down, you can see D 10.6, 10 millisecond is there. Okay, you can see the difference D. Along with the cursor, it is attached now. So this is the reference point from here to here. Here difference is 5 milli. Okay, some 5.3 milli. Here it is, one complete cycle is 10.6 millisecond. You take the reciprocal of 10.6 millisecond, that is the frequency. Okay, if you want to increase the frequency, you have to increase the delay here. If you have to change the delay here, for example, here instead of 922, I can give 2000. I declared as int, no, so 2000 also I can give, no problem. You have to stop debug and you have to do. So then you can get, for more delay it will be on. So start debug, and once again automatically previously opened, no, so it will be there. Just click on run button. See, now the width is increased. I changed it to 2000, that's why. So this is how to change the frequency. You have to change the delay. Okay, if you want to have square wave, on time and off time are same, so same delay program we are calling. If you want to have rectangular waveform, two delay programs you have to write. Okay, and delay 1 and delay 2, different counts. So then you'll get on time, off time, different. Here it is pure sine wave, sorry, square wave. So on time is equal to off time. Okay, this is how to see output. Thank you.